Hello everyone. In today's session, we are going to discuss about the conversion of Epsilon-NFA to NFA. In the last session, we have discussed about how to convert a regular expression to Epsilon-NFA to DFA. And we also discussed this NFA to DFA conversion. Okay, so first of all, we should know why we need all this conversion, why we want to take one form of a finite automata and convert that into one another format. Okay, so this is actually to prove the equivalence of each and every automata. Equivalence means like whenever there is a regular language, we can construct any one form of this expressions, might be a regular expression or NFA or DFA or Epsilon-NFA. If you are able to come up with one particular notation, one particular way of representation, it can be converted into anything. Okay, so when you take a DFA, it can be converted into one regular expression. When you take an NFA, NFA can be converted into a DFA. So everything is done to prove that they are all equivalent, everything except a regular language. So for a particular language, when you are able to construct one form like a regular expression, then there exists an Epsilon-NFA, NFA and DFA for it, for sure. Okay, so this is proven using this conversion method. Okay, so today's session, we are going to take an Epsilon-NFA and I'll show you the steps involved in converting that into an NFA. Okay, it is a kind of thing like what we have discussed in your previous sessions. Like in the previous session, we have discussed this NFA, Epsilon-NFA to DFA, right? Like rather than going for that complicated thing, we are just going to use the table for constructing it. So first of all, I'm just going to take a table. I'm just going to draw the transition table for this Epsilon-NFA. So here my states are A, B, and C, where A is my starting state denoted like this and C is my final state denoted like this. And your input symbol here are P, Q, R, and it is an Epsilon-NFA, right? So you have this Epsilon transition too. So construct a table like this with all the inputs on the top and all the states over here. Okay, now this is the transition table for my given Epsilon-NFA. Now, on state A, when the input is P, it has a self-loop transition, so it is going to stay in state A itself. Got it? So A, when the input is P, it stays in A. And A, when the input is Q, you don't have any transition, so this is going to be null. A, when the input is R, you don't have any transition, it is going to be null. And A on Epsilon, it goes to B. Okay, so Epsilon-NFA is a place where you have all this Epsilon transition also included. So you have to include that as a one input symbol as it is. Now, similarly for B, when the input is P, you don't have any transition. And B, when the input is Q, it is a self-loop condition. It goes to itself. And B, when the input is R, you don't have any transition. And B, when the input is Epsilon, it goes to state C. And similarly on C, you don't have any transition on P or Q. It is going to be null here. And when the input is R, it stays in C itself. Okay. And C on Epsilon, you don't have any transition. It is null. Okay. So this is very easy. Like you have to look at the diagram and just construct the table. Now the next step is I'm going to find all E-closure set. Like what we have done for your NFA to DFA, Epsilon-NFA to DFA. Here we have three states. I'm going to find all E-closure set. Epsilon closure of any state is said to be like when I want to find the transition on Epsilon closure on A, I'm going to find all possible places where I am able to reach with Epsilon as an input. So Epsilon is a category that we don't have any input. Without any input, if there is a possibility to move on, then that is called an Epsilon closure. So A, when the input, you don't have any Epsilon here. Okay, so when there is no input, A will stay in itself, right? So that is possible. And A on Epsilon, it goes to B. So without consuming any of the input symbol, it has a possibility to reach B. And B on Epsilon, like A on Epsilon, it has a possibility to reach C. So we are clubbing all Epsilon path together and you're going to assign it as E-closure set. Got it? Now what is E-closure for B? B on Epsilon, it stays in itself, and B on Epsilon, it has a transition to C. And C's E-closure set, C without any input, it has a possibility to stay itself. And on epsilon, you don't have any external path. I'm just going to close it like this. Okay. Now this is your A's transition, sorry, E-closure set. What I have done so far, I have constructed an Epsilon-NFA's transition table, E-closure for all the states. Now what I'm going to do, I'm going to create an NFA out of this Epsilon-NFA. So whenever I'm going to create an NFA, my set of states are going to be same as that of my Epsilon-NFA state. So here, I'm going to use this transition table representation again. So my transition table consists of A, B, and C. As it is mentioned in your Epsilon-NFA, A is going to be my starting state as it is. And my input symbols are P, Q, and R. I don't have an epsilon here. The same transition table, I'm going to rewrite in a new format. Okay, and why I haven't included epsilon here? It is an NFA. NFA doesn't have any epsilon transition here. It can have any number of transitions or null transition, but epsilon transition is not allowed in this case. Okay, so now how I am going to fill this table? I'm going to find the transition for it. Okay, the way in which I'm going to fill the table is for each and every, like I have 9 columns into it, 9 cells, and each and every cell has a transition. State A, when the input is P, I have to find wherever it goes. Okay, now to expand it, the transition of A comma P can be given as epsilon closure of transition of epsilon closure set of A on input as P. Okay, so what I'm going to do, I'm going to find all possible epsilon path of A together, and I'm going to find the transition of that on P. Okay, so wherever it goes, I'm going to take that transition, and for that, I'm going to find this E-closure again. So it is epsilon closure of transition of A on A, E-closure A consists of A, B, C. So it is transition of A on P, I have to find the transition, union transition of B on input as P, I have to find the transition, union transition of C on input as P, I have to find the transition. Okay, so what I have done here is I have taken this E-closure set for A. It is A, B, C. So for A, B, and C, I'm going to find the transition on input as P. So what happened here? It is epsilon closure of what is transition of A on P here? A on P. I'm going to copy it from this Epsilon-NFA table. A on P goes to state A, union. B on P, it goes to null, and C on P, it goes to null. So it is null transition. So that is equal to epsilon closure of A. And what is epsilon closure of A? It consists of A, B, and C. Write it over here. This is how you have to find the transition. A, B, and C. Done. Similarly, we have to repeat it. Now I'm going to find the transition of A on Q. So when I find the transition of A on Q, it is E-closure of transition of E-closure. Like some of the students will forget to include this E-closure set at the end. You have E to epsilon closure in each and every step. Epsilon closure of state A on input as Q. Okay, expand it. It is epsilon closure of transition of E-closure of A consists of A, B, and C. So I'm going to find the transition of A, B, C on input as Q. So what happened here? It is E-closure of A on Q. A on Q, you don't have any transition. B on Q, you have a transition to B. C on Q is null transition. So it is E-closure of B. Got it? I have just clubbed the steps together. You have to expand it like this. Transition of A on Q, union transition of B on Q, union transition of C on Q. Write everything and you'll get it. Now, what is E-closure of B? Epsilon closure of B is, it's B and C. So write it over here. It is B and C. And similarly, you have to find the remaining transition. Now, transition of Transition of A on C, I'm going to expand it as epsilon closure of transition of epsilon closure of state A when the input is C. Okay, so you have to expand it. It is epsilon closure of transition of E closure of A consists of A, B, and C when the input is, okay, it is R. On R, I'm going to find the transition. Okay, so what is it? A on R, A on R, you don't have any transition. B on R, you don't have any transition. C on R, it goes to itself. Okay, it is E closure of C. What is there in E closure of C? E closure of C consists of C alone. Add it here. Similarly, we have to fill the entire table. What I'll just do the do all, like you have to find the transition of B when the input is P. Okay, when the input is P, that is equal to E closure of transition of epsilon closure of B on input as P. Okay, so what is there in epsilon closure of B? Epsilon closure of B consists of C here. It is B and C, right? So I'm going to include it here on, it is transition of B comma C when the input is P. Okay, so what happened here? It is E closure of B on P. When the input B on P, you don't have any transition. It is null. And similarly, C on P is also null transition. So B, when the input is P, you don't have any transition. C, when the input is P, we don't have any transition. So both the cases are going to be null here. So finally, your result is also null. And this null is accepted for your NFA. So NFA is a place where you can have your multiple transition or null transition. When it comes to DFA, you have to have exactly one transitions inside, right? Like in the table, when there is only one state represented, we call it as a DFA. Whereas NFA is a place you can have multiple possible states or you can have a null transition too. Got it? So I'm going to do the same for transition of B when the input is Q, right? All possible transition here. It is E closure of transition of epsilon closure of B when the input is Q. Okay, that is equal to epsilon closure of transition of E closure of B consists of B and C. And on input as Q, we have to find the transition. Okay, so B on Q, where it goes? B when the input is Q, it goes to itself. Okay, and C on Q, it is null. So you have to write this E closure of B alone. Okay, so B on Q, it goes to itself. Right, you have to check it from the table. B when the input is Q, it goes to itself. C when the input is Q, it is null transition. So what is E closure of B here? It consists of B and C. Fill the table over here. It is B and C. Okay. Now I am going to find the transition of B when the input is R. Okay, expand it. It is epsilon closure of transition of epsilon closure of state B when the input is R. Okay, so how can you expand it? It is epsilon closure of E closure of B consists of B and C when the input is R. So what happened with R's transition here? B on R, it is null transition. C on R, it is C. So this as a whole becomes C. And what is E closure of C? Epsilon closure of C is, again, it is C. I have combined two steps together. Okay. Similarly, find the transition of C comma PQR. C comma P consists of epsilon closure of E closure of C on input as P. Okay. So what is epsilon closure of C? Epsilon closure of C consists of C alone. So that is equal to epsilon closure of transition of C on P. So what happened with C on P? C, when the input is P, you don't have any transition. So this path become null. Okay, so this become null. And similarly, I'm going to find the transition of C on Q. Okay, it is epsilon closure of transition of same E closure of C when the input is Q. Okay, and epsilon closure of C consists of C alone. C on Q, what happened? C when the input is Q, it is null. So this is also going to be null. Okay, since epsilon closure of C consists of C alone, C when the input is P or Q, you don't have any transition. So here also it is going to be the same. C on P or Q, you don't have any transition. Now, when you are finding the transition of C on input as R, you have this C on R, it goes to C itself. Okay, so it is epsilon closure of transition of E closure of C consists of C alone, and C on R, it goes to C. So it is E closure of C, which is equal to C. Okay, I have combined 2-3 steps together, and this is my final transition. And I cannot call it as a final transition since like the tuple notation for any NFA or DFA can be expressed as you have 5 tuples, right? You have set of states, input, transition, starting state, and final states. So Q is set of states. My NFA consists of ABC. Epsilon is my inputs. So PQR is my input. Transition is expressed using this 9 transitions. And Q is my starting state. So here A is my starting state. And I haven't defined this final state, right? So how can you define a final state? Listen carefully. Over here, I have taken this transitions of the state as it is. Like here ABC are my states and here also ABC are my state. Now what I'm going to do, whichever state has the possibility of making it as a final state is one where when I take A, okay, if A is there, if there is any possibility of reaching to the final state with epsilon, then that can act as a final state. So what I'm going to do, I take this A, B, C state and C is the final state of your Epsilon-NFA. So whichever place you have C, that will act as a final state. Okay, so the reason is from this state, without consuming any of the input symbol, we are able to reach the final state. So that state has a possibility of acting as a final state. Got it? So all your states of A, B, and C has the possibility of becoming a final state. Okay, so this is your final NFA. If you want to draw the diagram, I'll do it here. Okay, just based on your transition table. I have the states as A, all final. A starting state can be a final state too, no issues. B and C. Okay, now A, when the input is P, it has a transition to itself, A, or it make a transition to B, or it make a transition to C. Got it? This is your speciality of NFA. From one state on one input, it has a multiple places where it can go. Either it can stay in A itself, or it can make a transition to B, or it can make a transition to C. And now A, when the input is Q, it has two possible transitions. One is it can have a transition to B or it can have a transition to C. Okay, when it is Q, when the input is Q, it has two possibilities. And when the input A, when the input is R, it can have a transition to C. Okay, I'll write it. A, when the input is R, it can have a transition on C. Okay, so this is just A's transition. Now coming to B. B, when the input is P, you don't have any transition. B, when the input is Q, it has two possible transitions. So one, it can stay in this place. Okay, this place on when the input is Q, and B on input as Q, it can have a transition to C. Okay, now I'm sorry, I have forget to add it here, PQR. Okay, so it is A to C, you have a transition on. See, A to C, you have a transition on P, Q, and R. I have changed it. Now, finally, B, when the input is R, it goes to C. When the input is R, it goes to C. And for C, on P, you don't have any transition. On Q, you don't have transition. And finally, on R, you have a self-loop condition. Do it here. when the input is R. Okay, so this is your final NFA for the given epsilon NFA. Got it? Thank you.